For those of you who may not know, the Academy Forum is a program that is organized and funded by PAMCA. It is to bring to campus outstanding speakers who will engage our students and our faculty and our families. And it is also our pleasure to be able to open it up to the larger community. So we welcome you all. We're really delighted that you've braved the elements to join us tonight. Before we get going with our program tonight, there are just a couple people that I want to thank for making it possible for us. First, Amy South. Amy, where are you? Amy's around somewhere. Amy is our community vice president. There she is in the back. She's ultimately responsible for the entire event tonight. Next is Lucy Batzik, and Lucy is in the doorway up there. Lucy has executed every single detail for tonight. We have Trish Perlmutter. Trish has shepherded this program from the very beginning. And last but not least, Judy Polinovsky and Debbie Kozak, who make absolutely everything happen for us here at MKA. So thank you very much. So now, without further ado, it's my pleasure to introduce the headmaster of the Montclair Kimberly Academy, Tom Namick.
Well, good evening and welcome. I'm delighted to welcome you to the Montclair Kimberly Academy, and I want to also thank again our Parents Association. They have made this evening possible for us. While the program is free of charge, it's not free of expectations for how we will conduct ourselves as an audience. I have a couple of things I'd like to ask of you. Please, there's to be no electronic recording, audio or video. Please don't hold your phones up to take pictures, mostly because it distracts the people behind you. And we'd really like to focus on our very special guests this evening. It's my privilege to introduce our guests, and I think they're well known to all of you, but I do want to say a couple things about them. Dr. Tyson has been a frequent guest on the Colbert Report, or rapport, I guess is the proper pronunciation. We're delighted that he's here, and we are also delighted and very grateful that Mr. Stephen Colbert has agreed to interview him for our benefit. Stephen Colbert, comedian, author, and host of the Colbert Report, is both one of the funniest and possibly the bravest comedians of our time. I want you to consider his performance at the National Press Club dinner in 2007. As he stood just a few feet from the President of the United States, known to the rest of us as the most powerful man in the world. Dr. Neil deGrasse Tyson, astrophysicist, director of the Hayden Planetarium, author of 9 books, teacher, lecturer, host of NOVA's 4-part series Origins, and member of 2 presidential commissions on the United States aerospace industry and the future of our country's space exploration. Dr. Tyson has a gift for working successfully within the realms of research, education, and policy formation. I owe you all an explanation about our theater tonight. What you see on stage is the beginning of a set for a 7th grade production of Romeo and Juliet. This year's selection for what is, as I said, an annual performance. And I think it's fitting that Dr. Tyson is going to warm up the stage for the 2 most famous star-crossed lovers in all of American literature. It occurred to me that there are a few things that Stephen Colbert and Neil Tyson have in common, and I wanted to comment on them. Both of them share an overarching purpose to make sense of the world. They also share a common strategy. They often look to the stars, human or heavenly, for evidence of how things work. Though Stephen Colbert is far tougher on the objects caught in his gaze, whereas Dr. Tyson is only known to have obliterated Pluto. They share methods in their respective fields, whether it is the search for evidence that makes sense of the world and the universe, or the creative construction of questions and tests by which the truth and significance of who or what is before them are evaluated. Perhaps then they both have something in common with William Shakespeare, the desire to provide their audience with a lens to see the world from a previously unconsidered point of view, and not just as others would have us see it. So while the stars may be dazzling, training and instinct appear to have taught each of them to look away from celestial bodies. I'm really sorry, I have to get that bad cliche in there somewhere. And to consider the effects that those celestial bodies have on everything and everyone around them. In addition to the challenging questions that each of them make us confront, their work has given the world a little more of that very rare and gem-like substance known as the truth, or in Stephen Colbert's case, truthiness. And we are very grateful. Ladies and gentlemen, Mr. Stephen Colbert and Dr. Neil deGrasse Tyson.
Romeo, Romeo, wherefore art thou, Romeo?
I don't know.
Neil, thanks so much for coming tonight.
Yeah, no, thank you.
Mr. Dr. Neil deGrasse Tyson is, he's been on my show 6 times. And often when I come out to greet the audience before I do my show, they ask me, who's your favorite guest of all time? And I say, not just for volume, but it's Neil deGrasse Tyson. Because not only do I love what Neil knows, but I love that he loves what he doesn't know. Always interested in the next thing to learn.
Oh, yeah.
And always roll to whatever idiocy my character wants to throw on him. I think the only time I ever surprised you, as you told me a little while ago, was I asked you, should scientists go to Argentina or hike the Appalachian Trail?
Yeah,
I want people to talk about them.
It's the universe talking
I
there.
think we're a little out there.
The universe amplifies. Yeah, that one, I missed that one.
Yes, you'd missed that news story.
Yeah. See, to go on a show, it's like the hardest interview ever. I have to I'm laden with current events just to mix with my science because I don't know where he's going to come at me. And I got to be ready with 7 tennis rackets to hit it back. And I'm upset because that one news story, remember with the guy, was it South Carolina guy?
Who remembers?
He goes to Argentina and becomes well known for having done so. And you asked me straight out, should scientists visit Argentina more often to become better known? And it just went, you aced me on that one.
You're welcome. Now, Neil, we've got a lot to talk about tonight.
Yeah.
A lot of subjects. Science is a big thing. But I want to start off with, this is not a bribe.
Okay.
I want to start off with...
What's these chairs? I feel myself sliding.
No. Exactly. When we first walked in, I said, oh, welcome to the barn raising. I realized we were speaking before the Amish tonight. Now it's going to make it tough to talk about science and technology. All right, Neil, I want to start. I want to start in a broad way.
Are you tweeting now, or are you actually trying to interview me?
No, I'm just looking at photos of myself. Get a little work done. I need a little freshen up. Now, let me ask you a very basic question. Mm-hmm. Science, from scientia, in Latin, meaning knowledge.
I didn't take Latin, but I'll take your word for it.
Mm-hmm. Is it better to know or not to know?
I think, well, my blunt answer is it's better to know.
All right.
But
that is debatable, though.
Well, I said it's my answer.
Yeah.
I mean, somebody else might have a different answer.
For instance, Oedipus might have a different answer.
Yeah. Yeah, I mean, I think...
Is knowledge always a good thing?
I have to say yes.
Why?
Because it empowers you to react and possibly even to do something about it if something about it needs to be done.
Okay, but who we are is what we know, right?
Part of who we are is what we know.
And our identity is often based on how we see the world.
Yes, and our personality for sure.
And if we learn something that does not jive with how we think about the world, won't we have to re-examine who we are?
Yeah, it could mess you up. Yeah.
Once again, I'll go back to Oedipus. He plucked his eyes out rather than know anymore.
Yeah, well, people back then, they did stuff like that.
Yes, people back then, not people today.
So I think there are people who would not know, who would rather. I remember the old days. I don't know if it still happens. A doctor would find out if you had cancer, they wouldn't tell you. They wouldn't tell you.
Give it to me straight, Doc.
Yeah, and why would you even have to say, give it to me straight, unless there was a day when they didn't give it to you straight? If I have 5 years left, I want to know I have 5 years left. Because I'm going to, do something different in those 5 years.
Neil?
Yeah?
I have some terrible news.
But
there are some people who don't want, there are some people who don't value science. And if they don't value science, are they valuing ignorance?
Yes, but I will not pass judgment on them. What I will say is, if they are at maximal comfort in their ignorance, fine. Except that they will not be the participants on the frontier of cosmic discovery. They will be disenfranchised.
Hello? Hello? I'm sorry, I've got a phone call. Hello? Sorry, I have to take this. Hello? My mic isn't working?
Hello. Now who's in control?
So they won't be in control of the next participant.
No, they won't. Not only will they not be on that frontier making any discoveries, they're not in a position to enhance their life for having access to those discoveries themselves.
Can knowledge ever be a bad thing?
I don't think so.
What about actions that knowledge takes us to? Do you think that Oppenheimer, when the bomb went off, and he said, "I am become death, destroyer of worlds," do you think he perhaps questioned for a moment whether the knowledge they achieved that led to the creation of the bomb perhaps should have been left undiscovered?
Do you know what he said in response to those kinds of questions?
Yes.
He said, because people said, have you usurped the power of God? Have you? And he said, if God didn't want this power to be there, he shouldn't have put it in the atom in the first place. Kind of an interesting point, I think. What he's saying is that the world is accessible to us. So would you say, don't smelt the ore and make iron and make a sword out of it because you could cut yourself? Back then, that's the counterpart statement from the Iron Age. And if you were around back then, you'd be sitting in this chair saying, don't make the sword, because you would unleash evil on the world.
Okay, I'll step back from don't make the sword. How about don't lick the flagpole in February?
Yeah,
you will learn something. You will learn something, but at a price, Neil.
That'd be data. It's a data cost.
It is. Yeah. There is a data cost for that, isn't it?
Yeah.
Also, Adam and Eve. They ate of the tree of knowledge of good and evil, and they paid a price.
Yeah.
So God does put things into atoms he doesn't want us to know about.
However, I think I don't want to blame the knowledge. I want to blame the behavior of people in the presence of the knowledge. So maybe we need better knowledge management.
Do you think that scientists go? You can applaud him. He's the hero. Well, how about this? Do you think that scientists should be allowed to do anything they can?
I heard a big no over there. Someone just said no.
You know, people made fun of him for doing this, but during one of President Bush's State of the Union speeches...
Bush 1 or 2?
Bush 2.
Mm-hmm.
He said he warned against man-animal hybrids. Okay? And a lot of people, like me, made fun of that by showing pictures of, like, Senator Alligator Man going, boo, boo, yay, man-animal hybrids. But if scientists could make man-animal hybrids, wouldn't they? There are scientists who want to make man-animal hybrids. Should we make man-animal hybrids? I ask you, Senator Tyson. Should there be any limits like that?
I think there's some creepy things about that, and I've met some scientists who would think that'd be an intriguing thing to do.
Yes.
Okay? So I think we as a society, as a democracy, what we should do is come to some understanding of what the prevailing social mores are. And no, science should not cross those barriers. And by the way, scientists are often ones to try to prevent that. Einstein among them, for example. He didn't want to make the bomb after he first told Roosevelt he should make the bomb. He changed his mind because his conscience, his moral conscience, descended upon him. Scientists are not without moral code here. So as a culture and as a society, we decide what should be the prevailing cultural mores, and I think we should all be beholden to those.
What do you think of the portrayal of scientists in movies? Because often, for instance, the scientists who make the Terminator, they're the bad guys. Scientists lead us to the Terminator, or they create the superbug that wipes out the world, or they enrage the monster at the bottom of the sea.
When you part the curtains and at the bottom of all of that, there's a politician funding that research.
Is this working again? It is? No, it's not. He says yes, you say no.
Yeah, we got it.
We're getting bad data.
We're good. That was good.
That's good?
You're good.
Oh, yeah.
You're good. So scientists don't lead marching armies. Scientists don't invade other nations. Scientists, yes, we have scientists who invented the bomb. Yes, but somebody had to pay for the bomb, and that was taxpayers. That was war bonds. There was a political action that called for it. So everyone blames the scientists. We are collectively part of a society that is passing, that is using or not using, to its benefit or to its detriment, the discoveries made by science. And at the end of the day, a discovery itself is not moral. It's our application of it that has to pass that test.
Would you agree that there's a distrust of science on a certain level in our country? I mean, unless it's, going to grow my hair back.
Yeah,
the
right.
Science...
Or do other things to your anatomy, yes.
Right, exactly.
Yes.
Science, exactly.
Yeah.
Science, I've gotten those emails. Science is sometimes distrusted because it is more complex than the average person can understand.
I think that is the core of it. It's distrusted not because of what it can do, but because of because people don't understand how it does what it can do. And that absence of understanding or misunderstanding of the power of science is what makes people afraid of it. And so I remember back when they first split the atom, shouldn't split the atom, or shouldn't. I mean, you hear this at every discovery that happens in science. There's a mystery to it. For example, irradiated foods. In France, they call it frankenfood, all right? Which is kind of a cute word when you think about it. Yes. But it makes food last longer, and you're healthier for it. You don't get sick from it. And so from it turning bad. In fact, NASA does it all the time. NASA can make a slab of meat. You wouldn't necessarily put this in your refrigerator, but NASA can make a slab of meat that'll last 30 years. I tasted it.
And? Delicious?
No, it was, there's some restaurants' food reminds me of what that tasted like. But I'm just saying that just because you don't understand it doesn't mean it's bad for you. Go figure out how it works. That's why we need a scientifically literate electorate, so that when we go to the polls, you can make an informed judgment. And you can draw your own conclusions rather than turning to a particular TV stations to have your conclusions handed to you.
Now, Arthur C. Clarke.
Comedy Central accepted.
Exactly.
Okay.
Arthur C. Clarke's famous dictum about sufficiently advanced technology.
Yes, it is. Arthur C. Clarke had several laws of culture and the world, one of which was any sufficiently advanced technology is indistinguishable from magic.
So, if something gets too complex for the average person to understand,
it's magic.
It's
like
magic.
And you have powers that I don't trust because I don't know what you're going to do with it next. Whereas if you understood how it worked, you'd say, "Hey, give me one of those." I mean, that's how that would work. That's how that plays out.
Do you think that's where the debate over? I think that's where the debate over evolution and creation science comes. Is that the complexity of evolution is so grand that it is hard to conceive of how the incremental changes come. And once something becomes so complex that I can't understand it, there's nothing between that and God saying, let it be.
Well, one of the beauties of evolution is that that complexity does not come about from complex ideas. The ideas are actually quite simple. And you can show on a computer how those simple forces can generate complexity given enough time and enough variation in environment, which is just what the history of the Earth supplies. So science literacy is an important part of what it is to be an informed citizen of society.
Let's get away from our understanding of science, or lack thereof, and get to science itself.
Okay. I'm with you.
Here's a transition from talking about us mixing science and religion and getting back to science.
Mm-hmm.
God is truth, people think.
Mm-hmm.
Okay, some believe God is truth. Truth is beauty. Is there anything in science to you that is beautiful? Or rather, what is the most beautiful thing that you know of in science?
E equals MC squared.
Really?
Oh, it's awesome. It is.
So that equation doesn't just have a great publicist. It's actually... Because everybody knows it, but also everybody knows Coke. You know, it's like the Coca-Cola of science.
Yeah, you learn E equals MC squared before you even know what any of those symbols mean. You hear it in elementary school. It's a gorgeous thing. It's
what is beautiful about E equals MC squared? First of all, tell everybody what all the pieces mean.
Well, E stands for energy. M is mass. C squared is just the speed of light squared. That's just, ignore that for the moment. The thrust of that equation is that energy and mass are equivalent to each other, which means you can transmute one into the other and back. What makes it extraordinary is that that hardly ever happens in our everyday lives, yet it's going on all the time in the rest of the universe. And so
we're in this little pocket where E equals MC squared is not visible.
It's not visible. It's not happening in our lives. No. But if it did, the world would be really different. Light coming from that bulb would all of a sudden pop into a particle, and the particle would combine and pop back into light again.
Would it hurt?
It can, yeah. It would sterilize you. There's a lot of, the kinds of particles that would do that they would sterilize you, yeah. That'd be bad.
I've had my kids.
Yeah. So it goes on in the center of the sun. It went on at the Big Bang. It goes on throughout the universe, wherever it's hot and heavy. That's what.
But what is beautiful about it to you?
It's simple. It's simple, yet it accounts for hugely complex things. And for me, that is where the beauty lies in the truth.
No.
If I had to give you a complex theory to understand a complex phenomenon, send me home. Because what's the point? Now, there's no tablet in the sky that said it had to be simple to end up being complex. That's just a remarkable fact about the universe. So why not celebrate it? The fact that pi, right?
Let's say the numbers together. 3.1415926.
We got a few geeks over there.
That's a nerd fest.
We got a geek thing going on over there.
Not bad.
The fact that you take a circle of any size, a circle the size of the universe itself, and divide it by its own radius, and you get that number, that's beautiful. I have to pause, and I get misty thinking of this. I'm sorry, that's just another one, that the atoms and molecules in your body are traceable to the crucibles in the centers of stars that manufactured these elements over its lifespan, when unstable, on death, exploding its enriched guts across the galaxy, scattering it into gas clouds that would ultimately collapse and make a star and have the right ingredients to make planets and people. Which means we are part of this universe. As I've said many times, and this goes back, not only are we in the universe is in us. That is a profound concept. And it was, I think it's the greatest gift that astrophysics gave culture in the 20th century. There's a research paper in 1957, and I say that because one of the authors just died, like 2 days ago, Jeff Burbidge. Burbidge, Fowler, and Hoyle. One of the most famous research papers that no one ever heard of. You know why, I think? Because it had 4 authors, not just one, and it took a decade to figure out, and it wasn't just somebody burning the midnight oil, so it doesn't lend itself to poetry or screenplays, because it's a collaboration, so nobody wrote about it. But we knew that we are star stuff. We knew that we are stardust at the middle of the 20th century. That connects us to the universe like no other fact. That's beautiful.
Sounds like you have written poetry about it.
Once it gets in you, you have, the only way it comes out is poetically. No!
You write poetry. You write sonnets.
I don't know if they're sonnets, but occasionally a word rhymes in it, and I don't know what to call it. But sometimes if you feel deeply about something, I think the greatest poetry, not that I'm an astrophysicist, right? That's my disclaimer. Mm-hmm. But some of the greatest poetry is revealing to the reader the beauty in something that was so simple you had taken it for granted. That, I think, is the job of the poet. And so, the simplicity of the universe, which started this part of our conversation, I think, if it doesn't drive you to poetry, it drives you to bask in the majesty of the cosmos.
So what drew you? You said that this is the beauty of astrophysics, or the gift that astrophysics gave us in the 20th century. What drew you to astrophysics? Take us to Neil deGrasse Tyson before he's an astrophysicist. Take us to who you are now.
I'm living in the Bronx, which in vernacular would be the Bronx. And I'm in a building...
Not a lot of stars.
No, there's like a dozen or so in the night sky. So you do not have a relationship with the night sky as a city dweller. And my parents, I have a brother and a sister, they would take us to, each weekend we'd go to visit museums and other sort of cultural things in the city. And one of those weekends we went to the Hayden Planetarium. The local planetarium, the one right there in Manhattan. And you sit in the chair, and the lights dim, the stars come out, and I said, "Oh, that's a nice hoax, that can't be real. I'll enjoy it while there's it, but that's fast. They think there's that many stars up there. Like, what kind of, are they pulling my leg?" And a couple of years later, I go out to Pennsylvania in another trip we took, and I looked up at the night sky, and what persists to this day, and what is an embarrassingly urban thought, I look up at the night sky from the finest mountaintops in the world, and I look up and I say, "It reminds me of the Hayden Planetarium." It's embarrassing. See, I beg forgiveness.
Wow.
But so strong was that imprint that I'm certain that I had no choice in the matter. That, in fact, the universe called me. And I wonder that if I'd grown up on a farm and the universe and the sky was just always there, I wonder if that would just have become wallpaper to me, and I wouldn't have then been struck by it as I was at age 9. I'd never known anything of it. And then it just slaps you in the face. And from then on, I was hooked. It took 2 years for me to figure out you can do that as a career. But starting at age 11, you asked me, that annoying question adults ask kids, what do you want to be when you grow up? I heard a comedian say, you know why they ask? Because they're looking for ideas. Paula Poundstone said that. If you had asked me from age 11, what do you want to be when you grow up, I would have told you flat out astrophysicist. And my whole life aligned to that. Got a telescope, got a camera, photographed it. All my science fair projects. One was getting the spectra of the sun and analyzing features in the spectra. I built the spectroscope. So I was like nerd kid, card carrying. But I was bigger than other kids, so I was insulated from a lot of what might otherwise happen to nerd kids.
But you wrestled, too.
I was captain of my high school's wrestling team.
I've seen you in that wrestling outfit.
Oh.
You can rock a singlet. Well done. Now,
singlet is what you call the one-piece...
they know.
No, okay.
So... You wanted to become an astrophysicist. That leads to another question, which is, Is it better to not to know? It's better to know. Can it be beautiful? Yes, it can be beautiful. Is science a thing, or is it a way to look at the world? Is it a verb, or is it a noun?
It is both. The world is not just, is it this or that? Is it a planet or not a planet? It's sometimes...
You must choose.
It's fuzzier than that. Sometimes...
So if I have a lot of facts in my head, if I can absorb a lot of facts, am I a scientist?
No, you're a fact memorizer. In fact,
I'll accept that as a compliment.
Our academic system rewards people who know a lot of stuff, and generally we call those people smart. But at the end of the day, who do you want? The person who could figure stuff out that they've never seen before, or the person who could rattle off a bunch of facts? At the end of the day, I want the person who could figure stuff out. And science...
If we're trapped on an island.
Exactly. What, the professor on Gilligan's Island? It's not a matter of how many facts he can recite. It's like, there's a coconut, and there's a thing, and you have a ham radio. That's
exactly.
Okay?
Seawater, you
stir in the salt water.
You hook the wires up to Gilligan's fillings, and you listen to his ear.
Listen in it. So, it's an understanding of the relationships.
While we're on it, Ginger or Marianne?
Totally Ginger. Ginger. Complete. That was like, she came around the wrong time of my life. I'm telling you. It was like Ginger all the way. For sure.
So it's a way of approaching the world.
It's a way not only of approaching the world, it's a way of equipping yourself to interpret what happens in front of you. I think of science, the methods and tools that enable it, as kind of like a utility belt that you walk around with. And you come upon something.
Are you a superhero?
Yeah.
In your mind, are you a super science?
Actually, when I was a kid, I wanted to be Mighty Mouse when I was a kid.
Really?
I wanted to sing opera as I went to sing.
Here I am to save the day.
Yeah.
So it's a tool belt. It's a tool belt.
It's a utility belt.
Utility belt, sorry.
Because
I'm picturing you in the singlet with the utility belt.
Yeah. It's a tool belt. The difference is a tool belt, if you have a hammer, as they say...
You can hammer in the morning.
You can hammer in the morning. If I had a hammer. The problem is, if you start wielding a hammer, then all your problems look like nails. And maybe they're not. Maybe it's more subtle than that. And so your toolkit has to be able to morph into what is necessary for what it is that you confront at that moment. And so, yes, you're equipped with methods of mathematical analysis, methods of interpretation. You know some basic laws of physics. So when someone says, I have these two crystals, if you rub them together, you'll get healthy. So rather than just discount it, because that's as lazy as accepting it. Both of those are just lazy brain. What you should do is inquire. So do you know how to inquire? And every scientist would know how to start that conversation. They would say, well, where'd you get these? What kinds of ailments does it cure? How does it work? What does it cost? Can you demonstrate that it works? And you go through this whole, and at the end the person's in tears because they weren't prepared for that level of questioning. And so science literacy is vaccine against charlatans of the world that would exploit your ignorance of the forces of nature.
Neil, if you don't like the crystals I gave you, you can just say it. And they're not working for you because you don't believe.
Is there any science fiction you admire or that you enjoy? Or do you see the holes in science fiction and go, I can't enjoy that? Of course he would know the effects of a neutron star. He doesn't know tidal forces? Like, do you have that problem?
You've got that right. You've got that right.
Do you have that problem?
I only have the problem if the movie is marketed for its accuracy. Number one. Number two, they got to get some basic science right. After that, I'm okay. So, for example, in the latest Star Trek movie, they had this liquid.
The red matter.
The red matter, thank you.
Release the red matter.
Release the red matter, and you drop it into the core of a planet, and it turns a planet into a black hole. I thought that's kind of cool. No, what was a little weird was...
Why didn't it turn the ship into a black hole?
No. Because they had the special apparatus that surrounded it.
And the apparatus did what?
It's the anti-black hole apparatus. I'm okay with that. See, I was not losing sleep.
That didn't bug you?
Over what held the black hole. I didn't have an issue with that. But oddly, what I had an issue with was they needed this drill, which was a very cool kind of, that was the coolest thing I'd ever seen.
Exactly.
A drill that would drill to the center of your planet, and they dropped I'd say, if that would turn a planet into a black hole from its center, it surely would turn a black hole turn into a black hole from its surface. So
But then what would Kirk and Sulu fight on?
I know, right? They had to fight on the platform. So I'm okay. I got angry with Jim Cameron about Titanic. That's how I got angry. Did I tell you? I didn't tell you the story.
You did not.
Oh no! Can I?
I've never seen you this angry before.
Just hold me back.
I can't wait to see what you have to say about Avatar. You might turn blue with rage. Go on. So what was your problem with Titanic?
There's a colleague of mine who saw Avatar, and he got home and he told his wife he wanted to paint her blue, and that didn't go over very well.
Is she 10 feet tall?
So Titanic, you may remember, was marketed as a film of high accuracy because Cameron had funded this submersible to go down and it checked out the staterooms and the wall sconces and the china patterns, and so they reproduced that to detail. And so here they recreate the ship for the movie. Can you double check that? No, because he had the submersible. You just have to trust him, okay? No, you got to trust him. So now, the ship sinks, yes. Right? Did I give away the... You see the movie yet? I'm sorry. Okay, so the ship sinks.
I do, I remember.
You remember that, okay?
Very sad.
And it's Kate Winslet on the flow. Remember that? And
yes.
she's delirious.
This isn't the scene where she's naked.
Oh, sorry.
Go on, she's dressed. Okay, go ahead.
No, she's on the flow, on the whatever, the plank, and all right, she's looking up. We know the date, the time, the weather conditions, the longitude, the latitude. We know all of this about the sinking spot of the Titanic. There is only one sky she should have been looking at, and it was the wrong sky. Worse than that, the left side of the sky was a mirror reflection of the right side of the sky. So it was not only wrong, it was lazy and odd.
So halfway through, they just went, just flip it.
No one will know. And so I was livid. Ooh. I got out my finest stationery, and I wrote a letter to Jim Cameron. No reply. 5 years later, I bump into him. He was on the NASA committee, and my sort of presence with NASA was growing by then. And I bumped into him in a meeting. And I said, Mr. Cameron, I just have to ask. You know, the sky, it's not the right, it's black, what? And he says, well, actually that happened in post-production. So he's absolving himself of guilt. But I wanted him to grovel in front of my feet, which he did not do. Now, wait. So I was angrier after that. Later on, Wired magazine honors him for Discoverer of the Year, Explorer of the Year. And they want to hold their party at the Rose Center for Earth and Space. You don't come into my house and get the sky wrong. Okay? Is my microphone working? Or did it fall?
You're loud enough, you don't need a microphone.
There we go, it fell down. Can you hear me now?
Mine, yes.
Okay. So, he's in my house. And as a courtesy, they extended me an invitation to have dinner with a small group of them after this award ceremony. So I said, yeah. So we go to dinner. There's 6 of us at the table. The wine is pouring. So I said, Jim, I don't know if you remember, but I brought this up some time ago about the sky. And I wouldn't be so upset, except that everything else you boasted was so accurate. And we can't even check how accurate that is, but anybody can spend $50 for a planetarium sky program and look at the sky and know that you got the wrong sky. What gives? And you know what he said? He said, last I checked, worldwide, Titanic has grossed $1.3 billion. Imagine how much more it would have grossed if I gotten the sky right. That if I had a tail, it would have been like between my legs, and I would have. And
so I think you won that conversation.
No, actually, I did.
He retreated into his bank account.
here's what happened.
But that money will all eventually be gone, and he would still have gotten the sky wrong.
Oh, that's an interesting point. That's right. The sky will
outlive even James Cameron.
However, as dejected as I was, 2 weeks later I get a phone call. Forgot the guy's name. He calls me up and says, "Hello, it's Dr. Tyson." I said, "Yes." He said, I forgot his name, Johnny Smith. "I work in post-production for Jim Cameron. He is releasing a 10-year director's cut anniversary edition of the Titanic, and will be adding new footage from the deck. And he tells me you have a sky that he can use."
Not bad. You got your taste, right? You got a little taste.
Yeah,
it
was good. No, I'm not. I'm a public servant. Yeah. I don't need pizza today.
Me too.
So if you're gonna claim it's right, then I'm gonna hold you to it. If you're not, then I'll just sit back and enjoy it. What I don't like? I don't like is the people who you go see a movie with who read the book first. Get rid of them. They don't belong in the movie theater. All right? It's like, the book was better. Well, get the hell out of it. Get out of the movie theater. Then go back to your book. Leave me alone. Those people I can't stand. Stay home.
We should not go to the movies together. Now, okay, I got three different things. What is the latest discovery in astrophysics that we should all know about?
One of my favorite. I got to go back maybe 6 months for that. 8 months, may I?
Okay.
Okay. Well, we discovered water on the moon. That's kind of cool because where you're going, you want there to be water. All right, that's a good thing for life. But what struck me the most earlier in 2009, we discovered methane on Mars. Methane. If you have a gas stove and you live in a city, chances are it's methane. It's a flammable gas. You say, well, so what? Who cares? Except that methane is the byproduct. It's a part of the gaseous effluences of anaerobic bacteria, which on Earth operates deep in the intestinal tract of farm animals.
That's a very scientific way of saying there are Mars farts. That's what you're saying.
I didn't want to say it.
Yeah. You got a doctor in front of your name. You can't say stuff like that.
I can't say stuff like that.
But that means that is possibility, or is that yeah, there's life, but no one will come out and say it?
It means while you can generate methane other ways,
such as
sunlight. It's a combination of pressure, temperature, and energy source. You can manufacture methane.
Magic.
So, but chemical magic. Yeah.
Chemical magic.
But it is a natural byproduct of bacteria that thrive in the absence of oxygen. And you don't have oxygen deep in your intestinal tract, neither do any farm animals. And if you're down under and Mars doesn't have oxygen. So it's tantalizing to think that maybe there are life reservoirs in aquifers beneath the Martian soils.
As I was saying before about is it better to know or not to know, and there are things about our own identity that we take from the knowledge that we have,
yes, we do.
or the things that we don't know, the assumptions of things that are not there to be known.
And instead of using the word identity, I'd say they have an impact on our ego.
Yes.
Because the more we learn about the universe, the smaller we get, right? In time, in space, in size. And so if you go in...
Not the way you just described it. The way you described it, you're a supernova.
Well,
that makes you bigger.
Well, I think if you know about what's going on, then it's not mysterious and you're a participant in the unfolding cosmos. Otherwise, you are consumed by it and you fear it and you shun it. And you say, I don't want to know that I live on a speck called Earth, orbiting an undistinguished star in the corner of an ordinary galaxy in an expanding void of the cosmos. There are some happy thoughts in there, like understanding how that worked, recognizing that the human brain figured that out. That's kind of cool. There's a lot we still don't know, but what we do know, I think we can sit proudly and celebrate what we know about the universe. Maybe now, not every one of us figured it took a few key people like Newton and Einstein, but we learned what they taught us, and each of them stands on the shoulders of giants that came before them, just as the quote goes. Let's celebrate it, not fear it.
But if we found out that there was life someplace other than Earth, what do you think that would do to our identity or our ego?
It may signal a change in the human condition that we cannot foresee or imagine.
I think it would.
Now, I think the issue would be not if we find bacterial life, which is kind of what we're looking for now. Bacterial life, there's no question about whether in our mind's eye we reign supreme over bacteria, although
it can win.
The bacteria, do you know in 1 linear centimeter of your lower colon lives and works more bacteria than the number of people who have ever been born in the history of the world? So in fact, we are just hosts for bacteria to lead their lives. So from the point of view of a bacteria, we're just a place to live. A dark, warm place to live. But
we're a planet, and they don't believe there's bacteria in any of the other planets.
That'd be an interesting sci-fi novel. So the real issue is, if we find life on another planet that's smarter than we are, that would totally mess with our ego. That'd be the last, nail in the coffin of our ego. That used to be, well, we're humans, and we're on Earth, and Earth is small, and Sun is insignificant. That'd be the last one, and I don't know how we'd be able to handle that.
Do you think that there have been discoveries that have happened? For instance, I have heard discoveries that have changed our point of view about the universe that we are not aware of, that they've changed. In other words, the change has been so gradual, we don't realize we see the world differently. Has E equals MC squared, because that's coming up on 100 years?
I'll tell you. Yes, it is, actually. Well, no, we're past the age.
Last year was 100?
No, 1905, so 2005.
Okay.
But
so
I got one for you.
Has that changed us?
I got one for you. In the 1920s, which was a watershed decade in the history of science, in that decade, we discovered that not only our galaxy, the Milky Way, is not the only existence of anything in the universe, that there are other Milky Ways out there.
That recently?
1920s.
Was it just the optics didn't exist for that?
We needed a big enough telescope, and Edwin Hubble wielded all the glass that necessary to accomplish that back in the 1920s. He said Hubble, before the telescope, was a man and had his own telescope, the biggest of its day, and he made that discovery. That there were these spiral fuzzy things in the night sky. We thought they were just local to us. They're whole other systems of stars. 100 billion stars unto itself, outside of our system. Not only was that discovered in 1926, 1929 he discovers that the universe is expanding, which means it may have had back then, it may have had a beginning. If it's expanding, that meant it was littler in the past. Well, there must have been a day when it was all together in the same place. Thus was born the Big Bang. Okay, so now, also in that decade, quantum mechanics, quantum physics was discovered. That is the science of the small, the science of electrons, protons, neutrons, particles, nuclei. At the time, you'd say, this is just physicists burning tax money. Because who cares about the atom? I got my horse to feed. I got kids. You got issues in society. Yet it's quantum mechanics that is the entire foundation of our technological revolution. There would be no computers. There would be none of what you take for granted, your iPod, your iPhone, cell phones, the space program, without our understanding of the laws of physics as they operate on that atomic and molecular and nuclear level. And so the chemist has no understanding of the periodic table of elements without quantum mechanics. To them, it's just a list of elements. Quantum mechanics tells you why this column is there, and that's there, why this mates with that, and why that makes a molecule with that. That's quantum mechanics, and it's unheralded. You ask me, is there any discovery that has changed how we live? It is quantum mechanics. And I make this point because I'm ready to... Today you hear people saying, why are we spending money up there when we got problems on Earth? And people don't connect the time delay between the frontier of scientific research and how that's going to transform your life later down the line. All they want is a quarterly report that shows the product that comes out of it. That is so short-sighted that that's the beginning of the end of your culture.
So So it's better to know. That's a really long answer to my first question. My second question is, let's take some questions. Do we have time to do that? Q&A? You better wave, you better hit me in the head with a rubber band. Okay, very quickly before we get to questions here.
How many can I ask?
Ask one, do we have microphones or are we going around the room?
We can repeat the question if there aren't enough microphones to go around.
Let's start right here with just one, please, sir.
Is there a brown dwarf star approaching?
Is there a brown dwarf star approaching? Okay, dare I suggest that I think I know much more deeply about what's behind that question. He's asking about Planet X.
Do share.
That would swing by Earth in the year 2012 and tip us on our axis and have it be the end of civilization as we know it. Is that right, sir?
Oh, I heard about that.
Yeah.
I'm digging a subterranean chamber.
Yeah.
Me and my kids are going to be fine. Yeah, go on. Once again here.
It doesn't exist.
Moving on. Next question. Yes.
No, there is no Planet X. All gravity, all principal sources of gravity in the solar system are present and accounted for. Anything we discover now are tiny and insignificant, like Pluto's relatives.
Yes.
Anything to say about
Apophis. Apophis. An asteroid the size of the Rose Bowl. Discovered December 2004. Headed towards Earth. It's not alone among asteroids headed towards Earth, except that this one is headed, there's a whole set of asteroids that cross Earth's orbit. That alone is not a problem. You cross the street all the time, but at different times the trucks drive by, okay? So the issue is, are you crossing the street when the truck is driving there at the same moment? That simultaneity is what matters. Apophis, when you ran the calculations, showed that there was a chance of it hitting us in the year 2036, with a close approach in the year 2029 on April 13th. A Friday, by the way. But here's what's significant about that. We've had close approaches before, but none this close. This is the size of the Rose Bowl, and on April 13th, 2029, it'll come close enough to Earth to dip below our orbiting communication satellites.
Do you think 2.5% is a big number for that asteroid to come to Earth?
No, right now the best estimates are several in a million that it will hit us in 2036. And if it does, it will likely hit the Pacific Ocean, plunge into a depth of 3 miles, explode, cavitate the ocean, send waves of tsunamis. The first one from the impact. The second one, because the water splashes back into the cavity, goes high into the air, drops back down and sends another pulse. This will go on about 40 times. There'll be multiple tsunamis. I was just on the Santa Monica beach 2 nights ago because Santa Monica is the first city to get hit because it's the beeline right up from Santa Monica, 600 kilometers into the Pacific. 5-story tall tsunami would take out the entire west coast of the United States. But nobody has to die because we know this well in advance. But I think 2 people will die. The stupid surfer who wants to surf that tsunami, we know people like this, right? You see them. And you know who else, of course? The weatherman who wants to bring the camera guy closer. Can you see the waves hitting the shore? Okay, take him out too. We don't need either one of them, and then we'll get on with it.
That would be a great James Cameron movie. Yes.
Tonight there's a wolf moon. Can you explain what that means?
What's a wolf moon?
Okay, each full moon of the year has a name, and there are regional variations among those names. And the wolf moon, it's when it's snowy and the wolves howl. You can see the wolf in the light of the moon because the landscape is white, and the wolves don't turn white, so you can see them against this. And so depending on if you live in a region where there are wolves, that would be what you would call it. Other full moon names you've heard of, the harvest moon is one of them. The honeymoon is one. That's the moon that's in June, the honeymoon, because that moon actually never gets very high in the sky. And it's amber the entire time. It takes on the color of honey. It's just called the honeymoon, and you get married in June. And that's where you get the name honeymoon for that. Yeah.
Anyone over here? No? Yes, sir.
I think, in astronomy, probably dark energy was sort of a real game changer about 10 years ago, the discovery that the expansion of the universe is speeding up. If there's a game changer in the next 20 years, what is it?
The question is, dark energy He said 10 years ago it was like a game changer. Can I foresee any game changers on the horizon? Well, it turns out dark energy was not as much of a game changer as you might think. Because we already had a slot for it in Einstein's equations. We already had a placeholder. No one had ever measured it before. So we just assumed it was zero and got on with life. The moment it was discovered, we said, hey, now we can stick it in the equation. It's like, whoa! Its presence in the equation shows that there's this pressure operating against the action of gravity, making the universe accelerate in its expansion. And that's extraordinary, because it means that a day will come where these galaxies that Hubble discovered will move away from us with such speed that they will disappear beyond our horizon, and the total known universe at that time will only be the Milky Way, restoring the state of mind of our universe that existed before 1920. That's a spooky time. We would have to hand down the annals of cosmology from previous centuries to hear about the galaxies that were once in the night sky. So game changers going forward. If we discover the dark matter particle, that'd be kind of cool. If dark energy and dark matter, because we don't know what's causing either one of them, but we measure them. So they are real in their action on the universe. We just don't know what it is. Okay? As distinct from the ether 100 years ago, we never measured it. We just assumed it was there. There was no data. It was just dark matter, dark energy. We can call it Fred and Wilma. Don't think it's matter or energy. We don't know what it is. Don't let the name fool you. I'll for henceforth call it Fred and Wilma. Okay? So, with Fred and Wilma, these two things, it may be a game changer. Once we figure out what it is, it's a new particle that then we can exploit to our benefit. In the same way our understanding of quantum physics enabled us to exploit the behavior of atoms and nuclei to our benefit. So a new kind of physics would transform how we live. Yes, that's one way I think about it.
Is Pluto going to be excised, so not just because we send it out, but because the ice will expire quickly?
Will Pluto not only be humiliated by Neil deGrasse Tyson? You may not know this.
That's not the word she said. She used that word.
Excised from the family of planets. Neil was on the group that gave the recommendation that Pluto be demoted, correct?
We thought differently about Pluto's identity than Pluto did, and other supporters of it. We just grouped it with other icy bodies in the outer solar system that, at the time, were being discovered. Don't shoot the messenger. Pluto was alone for 65 years, and so you can't have a category of one. That doesn't work in science. You need a few things to make a category. So we said, okay.
It wasn't a category, though. It was a planet.
Well, yeah.
My very elegant mother just sat upon 9 porcupine. Now she just sits upon 9. It doesn't make any sense.
Yeah, it doesn't make any sense.
Where's the porcupine?
If she's that elegant, she wouldn't have sat on a porcupine, I don't think. So once we found other icy bodies, all we did was group them together. We said, Pluto, we found family for you. In fact, we think you're happier there, because now you're one of the biggest icy bodies. And rather than a pipsqueak planet.
You sent Pluto to a farm upstate to run and chase rabbits. It's much happier there, kids.
It's happier there. And I didn't do this alone.
Is there a supergiant beyond Pluto that pulls comets in? Is there a chance there's something out there that's drawing?
There was a hypothetical star, which is related a little bit to what led to this invention of this
the brown dwarf that you won't talk about, but you and I know. Yes.
Yeah. There was
come down to the bunker too.
There was a suggestion that there was a companion star to the Sun, provisionally called Nemesis, that had this long orbit that would jostle comets in the outer solar system and send them raining down on Earth, creating mass extinctions, accounting for the extinction episodes in the fossil record. But it was an interesting hypothesis that was never supported by data, and so when you're not supported by data, you discard the hypothesis. That's how science works. You don't believe something just because you want to, or think something's true just because it feels good. At some point, you've got to confront the data. So getting back to the point...
You've never been in politics.
So getting back to the point, the recognition that Pluto is made half ice and ice evaporates, so will Pluto one day disappear? No, Pluto's too far away from the sun for that to ever meaningfully evaporate and disappear completely.
Yes?
What was the point of the Large Hadron Collider?
What was the plan, did you say?
The point.
The point of
What
the Large Hadron
was the
Collider.
point? He speaks in past tense as though we're done with it. We
what
just
is?
turned on the switch, the Large Hadron Collider in Switzerland. The point of the Large Hadron Collider was to embarrass America, to make us feel bad that we didn't have our collider built back in the 1980s when it was first funded. That's the whole point of the Large Hadron Collider. It's Europe saying, "Ha! Gotcha this time." Now, apart from that ego bit, it's to probe nature on levels of energy never before seen. And right now, it's hard, it's practically impossible to discover a new law of physics on your tabletop. We've been there. We've done that. And almost the entire history of physics is go to the edges of your points of exploration and then take a step beyond that. You're bound to discover something new. It's like climbing the next mountain, crossing the next valley. So, the Large Hadron Collider, the energy inside that particle accelerator will exceed the energy of all accelerators that have ever been built before, probing nature as never previously imagined.
What is the Higgs boson?
Higgs boson, that's a particle proposed that you can think of it as a kind of a, it's like a, think of it like molasses. Okay? Well, okay, not molasses. It's a field through which all particles move, and the interaction of those particles with that field endows them with the mass that we measure for them. It is granting them the property of mass. We have yet to find this particle, but if we do...
So mass is not explained presently.
That's correct. If we just measure...
We don't know why we get fat. we don't know why something has mass right now.
That's correct.
And so we... Now, let me ask you something. If you build... let's say you build an equation this way. You've got an equation over here, you built it, and it's a house, okay? And you've got another equation over here that works. It's another house. But in your mind, you think, these two houses are actually probably should be one house. You invent something that fits into the shape between the two houses, right?
Yes.
Like you've got a shape between the houses. Goes, okay, there's something in the universe that is the shape of the space between these two houses.
Yes.
Does that necessarily mean that thing is there?
The history has shown that almost every time we propose something that connects one house to another, if those two houses themselves work, there's something in between them connecting the two. For example, in 1930s, we had this experiment with, it's 1930s, quantum physics is in place. We start probing the atom. We find out there's an atomic reaction, a nuclear reaction, where there's some missing energy. We account for all that, and there's something missing. We said this much energy here, and then it's missing here. And we swear we accounted for everything. Fermi comes up, a famous physicist, said, I bet there's a particle that came out of that reaction that escaped with the energy before you had a chance to measure it.
E equals mc squared.
Well, that would have endowed that particle with its energy to do so, the mass to do so. And even MC squared is in every one of these, it's all over the place. It's written with E equals MC squared. The point is, he hypothesized the particle, gave it the properties that it would have to account for what was seen. That's your conduit between the two houses. Then he says it's got to have this much energy, and it's got to be pretty hard to detect because we surrounded this in lead, and it just went straight through the lead. So I'm going to propose a particle that's hard to detect. And it's got to be little, because there's not that much mass, and it has no charge, so it's neutral. So he called them neutrinos, little neutral ones. He hypothesized. He said, let's look for them. 20 years later, they were found, neutrinos. And now we kept them coming out of these reactions. He built the porch, the walkway between the two houses. Practically every time you have two working understandings of the world, and they have to coexist in the same universe, there's something that's going to connect them. It's like electricity and magnetism, previously discovered as separate things, until Faraday and Maxwell said, hey, wait a minute, this works and that works, and they kind of smell like each other a little. Maybe they're the same thing. So a whole theory came out to put the two together, and it is the theory of electromagnetism. You know this word. You just take it as a single word, but those used to be separate concepts. So we're going good with this. We're on a roll here. So why not continue?
Yes, right there.
Do parallel universes exist?
Do parallel universes exist? We don't know. The parallel universes are losing favor to the multiverse. We have some cogent theoretical expectations that our universe might be just one of many, spawned from this sort of this hyperdimensional medium, which we'll call the multiverse. There's no data to support it, but we have good theoretical premise to think that it's there. And we have philosophical precedent. We used to think Earth was special and unique. It wasn't. We got 8 planets. We thought the sun was special. It's one of 100 billion suns. Thought the galaxy was special. No, it's 100 billion galaxies. We have one universe. Or do we? The track record said, why should there only be one? Be open to the possibility that you don't live in the majority-looking universe that's out there.
Would a separate universe, when you say different universe, does that mean
slightly different laws of physics, which makes
that's what I'm asking.
Oh yes. Well, this is the fun part, because if you manage to get a portal to another universe, don't be the first one to volunteer to go through it, because your atoms are working in this universe. If the slightly different law of physics, you could implode, explode, come out with 3 heads. Who knows?
There's a different exchange rate over there.
Yes.
Yes. Someone, let's go in the back, in the middle, and I think you have a white sweater on, yes.
Is it possible to tunnel through a black hole, like quantum mechanically speaking?
Can a black hole be used to travel? How about that? Can we say that?
No, it's a little different. Like,
Steve, get with
it. Tunnel through a black hole.
Yes.
As if it creates a tunnel in space or time.
Quantum mechanically is what she said.
Quantum mechanically, can you tunnel through a black hole? I'm not going to try to interpret this one.
Well, I have to ask, did you want to land someplace else when you're done, or are you content with being dead when it's over? I need to know before I answer.
I guess it's okay if I die.
It's okay if you die.
For science.
For science. Stephen Hawking showed just recently that, and for me this was kind of spooky amazing, that black holes remember everything that they have ever eaten. Which means it's not a tunnel to anywhere. Everything that it ate is sitting there at the singularity at its center. Now the spooky part, that's not the spooky part. The spooky part is, Stephen Hawking showed 40 years ago that black holes can actually evaporate. The matter that's within a black hole can rise up out of the gravitational field that surrounds it and spontaneously birth a pair of particles. That's just E equals mc squared doing its thing. E equals mc squared. The gravity field has high energy density. Out of that pops particles. And those particles escape, taking matter away from the black hole. From the gravity field of the black hole.
Doesn't that fly in the face of how we think of a black hole? In a black hole, gone forever. Because nothing escapes, because nothing can surpass the energy needed to go faster than the speed of light.
Except quantum mechanics, this quantum physics from the 1920s gets you out of that problem. That's a classical understanding of black holes. You layer quantum mechanics on it, weird stuff happens. Completely legitimately weird stuff happens. So you birth these particles outside the thing. Now here's what happens. I dump you.
That sounds like that. I'm not interrupting. That sounds like science is making magical exceptions for itself.
Quantum physics is kind of magic because none of it issues forth from your common sense. Particles pop in and out of existence. One time it's a wave, the next time it's a particle, and it interacts with itself. And you measure it here, but it shows up there. If we were forged in that world, then all that would be common sense. And equals mc squared would be a daily phenomenon. You wouldn't need Einstein to figure it out. He'd be learning it in elementary school. But that is a foreign universe to us. And so what goes on there, you are prone to say, that doesn't make sense. You know something? It's of no obligation to make sense to you because your senses didn't come out of that universe. Out of that universe of tiny particles. We don't live there. If you let something go and it drops, you say that makes sense. If you let something go and it goes up, you say that doesn't make sense. In quantum world, that happens all the time. It would make sense in the quantum world. So, I submit to you that if I take your body and dump it into a black hole, what Stephen Hawking showed is that all the particles that went into the black hole, let's say it's Stephen Colbert black hole, okay? No other contaminating bodies but your atoms in the center of this black hole. And I wait around, and out here, in the gravity field, particles pop into existence. And I make a check, how many protons, how many neutrons, how many electrons, how many neutrinos. By the time this black hole is evaporated, it would have been every single particle that you were having fallen in the first place. Extracted out of the energy field of the black hole. So it remembers who you were even out in the gravitational field. That's spooky to me.
Is the black hole now gone?
Gone. Gone. Just it pops out of existence. Evaporated. It takes, by the way, it takes several trillion years for that, so don't wait around for it.
It's that young man right there.
How do you figure all this out?
Okay.
How do you figure all this out? It's an excellent question.
Yeah, that's a good one. Isaac Newton did it all by himself. He was like really, really, really smart. A quick Isaac Newton story. He discovered laws of motion, laws of gravity. Just shows that planets don't orbit in circles, as Copernicus had thought, but in slightly flattened circles we call ellipses. And so a friend of his said, Ike, why? That may be quiet. I don't know what why that shape and not some other shape? He couldn't answer that question. I'll get back to you. Goes home for 2 months, comes back. Here's why it's that shape. They're conic sections that cuts through the thing. They said, well, how did you figure that out? He said, well, I had to invent integral and differential calculus to figure it out. So some people invent their own tools and methods to discover the world. Most people learn the tools from someone else and then apply them to make incremental changes. Some people make huge changes, like Isaac Newton and Einstein and others. Isaac Newton once said, if I can see farther than others, it's because I've stood on the shoulders of giants who have come before me. But I've read Isaac Newton, and his stuff makes the hair on the, if I had hair, it would rise up on the back of my neck, how plugged in he was to the universe. And I'm saying to myself, that quote cannot have possibly have been honest. What it really meant, if I'd re-give that quote to him, I'd say, if I can see farther than others, it's because I'm standing among midgets, that's why. He can see farther than everybody else. In the case of Isaac Newton.
I'm afraid we only have time for one more question. Yes, sir.
Actually, that was a great segue to my question. You talked.
We organize this all for your question. Sure.
Early in the evening, you brought up the ideas of scientific literacy and technology management. I'd like to hear your opinions on where the policy needs to go to make a positive impact in that area.
Ooh.
All right, Neil.
Can you repeat that for everybody?
The question is, we were talking earlier about scientific literacy and our approach towards science as a nation. In your opinion, and you serve on science advisory panels,
yeah.
Where do you think we need to go as a nation? What do we need to do to increase our scientific literacy?
I'll answer two-pronged. One is, what do you do with your kids? And kids need to be able to explore freely. And if you look at most households, they're not designed for that. They're designed to have the kid not explore. The kid comes into your kitchen and pulls out the pots and pans and starts banging them. What's the first thing you do as a parent? Stop that, you're getting the dishes dirty. Yet these are experiments in acoustics. That's what that is. Okay? Whatever the kid is doing, if it has the chance of breaking something, you're going to tell them to not do it, without thinking that that's the consequence of an experiment that they are conducting. And every time the kid wants to do something, provided it doesn't kill them, it's an experiment. Let it run its course, even if it makes something messy. You agreed to have a kid in the first place? Fine, clean up after them. And when they open up... Because it's those seeds of curiosity that is the foundation of what it is to become a scientist. Now, I don't want everybody to be a scientist. That'd be a boring world. I want the poets, and I want the musicians, and we need that. And I don't have it. But I'm talking about promoting science literacy. And so the first step for the parent is to get out of the way. Allow the child to explore. They start playing in the mud. Don't do that in the mud. I just cleaned those pants. You're getting in the way of another experiment. They start plucking the petals off the flowers you just bought from the florist. And you say, stop that, I just paid $10 for the flowers. Had you let that continue, they'd find in the middle the stamen and the pistil, and they'd learn something about the flower. For $10. That's cheap. Derek Bach, one-time president of Harvard, once said, if you think education is expensive, try the cost of ignorance. And so that's got to start at home. In the schools, I don't have a problem with the fact memorizing, but don't equate that with what it is to be wise or what it is to be smart. Smart should be some combination of that, yes, but also what is your lens on the world? How do you figure things out? And you promote that by stimulating curiosity. And I don't see enough stimulating curiosity in this world. This is a famous school right here. I saw the banner in the opening corridors. So you probably don't have that problem here, all right? But the whole world is not educated in this building. So a lot of change would need to happen in that regard. Now getting back to policy. I have tried. You do a simple Google, like YouTube and Tyson, my name, but put Neil so you don't get Mike. Right? Dining on someone's ear. Half of what ends up thrown onto YouTube are talks I've given where I'm trying to convince people, not only the public, but lawmakers and people in power, that investing in the frontier of science, however remote it may seem in its relevance to what you're doing today, is a way of stockpiling the seed corns of future harvests of this nation. And those seed corns, what they do is, whether or not you know it today, advancing a frontier, history has shown, has advanced a culture ever since the Industrial Revolution got underway. And we can speak more hegemonistically about it, that anyone who has embraced the powers of technology has enjoyed economic wealth, the likes of which the world has never seen, attendant with strength of security. Okay? And so people say today, they'll say, suppose the next terrorist attack is like a chemical attack. Do you call out the Marines, or do you get your best chemists to figure out what to do about that? There's a point where your weapons are not as useful as the brain of the scientist who you could bring to bear on the problem. And so I see science and technology and creative investments in it as the most significant infusion to our economy that could possibly be conceived. The problem is it's not going to boost the economy next quarter. It's got a time horizon longer than most people have the patience for, and most politicians have the re-election cycle to be tolerant of. So what we need is a longer view on those investments. I don't want to have NASA going hand in hand trying to get money to stimulate the frontier of cosmic discovery. And that frontier now involves biologists in the search for life, chemists in understanding the soils of Mars, aerospace engineers. You know what I don't want to do? I don't want to stand in front of 8th graders and say, who wants to be an aerospace engineer so that you can design an airplane that's 15% more fuel efficient than the one your father flew? That's not going to get them. But if I say, who wants to be an engineer and design the airfoil that'll fly in the rarefied atmosphere of Mars, I'm going to get the best students in the class, and you know it. Because that's an exciting project for smart people to work on, motivated people to work on. And when you have them, they invent stuff. They discover things. They transform the culture in which we live on a time horizon that is not easy to just tell someone in a one-sentence soundbite. And what I want is a level of science and cultural literacy that will allow the public to be able to think beyond the election cycle, to think for themselves and say, this is a good investment. How many times have you heard people say, if you're not among us here, why are we spending money up there when we have the problems down here? Have you ever asked how much money we're spending up there? Ask that question. You know what the answer is? I've asked people, how much money do you think we're spending? Here's your tax dollar. How much do you think? 10%? 15%? Those are the kinds of answers I get. You know how much is getting spent? The rovers, the space station, the space shuttles, all the launch vehicles, all the NASA centers is 0.6 of 1 penny on your tax dollar. 0.6 of 1 penny pays for it all. And you're telling me, why are we spending money there and down here? If you need that money to solve these problems, you got some other problems going on. Okay? That's a whole other problem with society. So, I'm sorry, I'm getting off. So my point is, I think the greatest, the greatest need is to be able to have the foresight necessary to make investments on the frontier of science, even if at the time you make those investments, you cannot figure out how that might make you rich tomorrow. Michael Faraday, in the 1840s, was the first one to pass a wire through a magnetic field. And it made a little meter tick it moved a meter. He hooked up to it. Now this guy, you do this and this happens. That's kind of cool. If you're nerdy, to a nerd, that's a cool thing, right? You do this and this happens. And so what was happening is, it induced a current through the wire. He showed his colleagues. It looked like just kind of a curiosity, a toy. Showed it to Parliament. They say, why, this is what we're funding? We're funding this toy? And this may be apocryphal, but it is said of Faraday, in response to this inquiry, said this, because they asked, well, what value is this to the British Empire and to the king? He said, I don't know what value it is today, but I know one day you're going to tax it. And in fact, that is the foundation of how all electricity is made today. And it would take another 60 years before electricity would come to homes. But who could have known it at the time? I don't want to be left behind.
I will not leave you behind.
Last thing I'll say.
Yes.
Last thing I'll say. The biggest news story last year to me was not the methane flatulence. No. The biggest news story happened December 22nd, something like that. I forgot what day. A press release comes out. Russia says they want to send a mission to deflect Apophis, the killer asteroid.
Oh, yeah.
By the way, I said if that hits, it's going to hit the Pacific, which affects us. Okay? Russia says we're going to launch a mission. We're going to start designing it now. We're going to fund it. Oh, by the way, the United States is welcome to join us. And people say, that's nice. A little international thing. I'm saying, wait a minute. Something's wrong here. Aren't we the ones who are supposed to be starting missions and invite other people to join us? Isn't that how it's been? So that was a sign, one of many, that our significance and meaning on the world stage is fading. And it's fading fast. And it's not a cliff. It's just a fade. And the day will come where the rest of the world just makes their own decisions about the future of their own space exploration and technologies. And we're sitting back saying, hi, fellas, can we join along?
Neil, we already proved we can deflect asteroids in the movie Armageddon.
Yes. So there's our fantasy. We don't do it in real, we do it on the silver screen, and we're happy about that. Maybe we got to fix that disconnect.
Last question. Why is there something instead of nothing? 10 words or less.
Just because. So I got to do this in haiku then. Okay.
Okay, 575.
Words that make questions may not be questions at all.
and well rebuked. Neil deGrasse Tyson, it is an honor to have you here and an honor always to talk to you. Please, come on, give it up for Neil deGrasse Tyson. Thank you.
Dr. Tyson is going to be down here. You will be signing books until 9:30, so if you'd like to come down and have a book signed, feel free. And for the rest of you, thank you all for coming, and get home safe.